Here we're given the determinant of two matrices. So these two vertical lines indicate the determinant. So we have negative 18 and 7. And we're supposed to use the properties of determinants to find the determinant of these four other matrices. So if we look at matrix A, the first thing we notice is that we have these two rows that are identical. And there is a property that says if any two rows or columns are identical, then the determinant is 0. So the answer to part A is simply 0 using that property. Now if we look at matrix B, none of the rows or columns are identical. And we notice B doesn't look like the first matrix, but sort of looks like this one here. But something's different. So you notice the first row, 0, 3, minus 2, matches the first column here, 0, 3, minus 2. So this is actually the transpose of this. So this matrix, if it were transposed, it would look like that. And there is a property that says that if you transpose a matrix, the determinant is the same. Right? So transposing a matrix doesn't change the determinant. So the answer will be 7 because the determinant of the original was 7. If we look at C, this looks very similar to that. But what's happened? We notice here that the first two rows have been switched around. So 6, 0, 3 is now here, and 0, negative 5, 4 is now the first. So we've switched two rows, and if you switch two rows, that has no effect on the magnitude of the determinant. It just changes the sign of the determinant. So if the original determinant was negative 18, now it will be positive 18. Now if we look at the last one, this looks nothing like this, but it does resemble this one here in the sense that 0, negative 6, 4 looks like it's the same as that, but multiplied by 2. Right, so it looks like we've taken the first row and multiplied it by 2. And we know there is a property that says if a row or a column is multiplied by a scalar k, then the determinant is also multiplied by k. So I guess the determinant would be 7 multiplied by 2. But wait, if you look carefully, you'll find that the second row is also multiplied by 2. So 3, 1, negative 1. If you multiply that by 2, you get 6, 2, negative 2. So the second row is also multiplied by 2. And the third row is multiplied by 2. So this 2 is multiplied by 2. So the determinant will be multiplied by k 3 times. So the determinant here will be equal to 7 times 2 times 2 times 2, or 7 times 2 cubed. So that's 8 times 7, 56. So the key is it's multiplied by 2 for every row that's multiplied by k. So in this case, 3 rows, so 2 to the power 3, 8 multiplied by 7, that gives you 56. So that's how you would use the determinant properties to find the determinants of these matrices.